Alright. Hello everyone. So now we are solving 433, which is minimum genetic mutation. It says that you are given a string, given two gene strings, start gene and end gene, and the gene bank, which is basically an array of this, written the minimum number of mutations needed to mutate stuff. Okay, so I just solved this sum, which was I think word ladder. Yeah, where this is pretty similar to that, where you are just supposed to generate this word using the bank of words, and you're supposed to generate this. And yeah, it was pretty similar. But I think the only change here is that your given choice is ACGT. So basically, in word ladder, you could just generate all the 26 possible characters, but here you have only four. So it's very similar to that. If you guys want to refer, you guys can check that video out. But I'm just going to go ahead with the solution here. I think that should be the solution for this as well, where I'll have a queue which will take in string, right? And this queue is basically keeping track of all the possible combinations which are valid. I'll have a hash set of strings, right? And this is basically a hash set for the bank. And I'll also have a hash set which will keep track of my scene strings, right? And then I'm going to do q dot add start point, right? And what I'm going to do is while my queue is not empty, right? So what I'm going to do is, since I need to return number of steps, I need to keep track of steps. So in steps will be 1 initially, right? And uh, I'm going to start from here, right? And at the end of this, I'm going to do steps plus plus. So it's kind of like a BFS search. And every time I do, I'm going to do q dot po. This is going to be my current string. And I'm going to check if this dot equals my end gene. If that's the case, I'm going to return steps straight away. Otherwise, I need to generate all the possible values. So what I'm going to do is okay, so I need the possible characters, carry of, let's say possible chars is equal to new char array of A, C, G, and T. Okay. Okay, and then what I'm gonna do is for char C for int I start. Oh, I can use j starting from 0, j less than current dot length, j plus plus. What I'm gonna do is I'm gonna use char C and possible chars. String new word will be equal to current dot substring of 0 comma j plus c plus j plus 1, right? And then I'm going to check if this new word is in my bank. So if that's a valid word, and my scene dot contains this new word, actually should not contain this new word, then I'm going to add it to my queue, and then I'm going to add it to my scene as well. Yep. And if at the end of this I still don't have it, that means it's not possible. I return -1. Yeah, this makes sense. Ooh, okay, so I failed here. Okay, so I messed up something. Let's see. So I added a start gene with steps 1. I'm going to start with this. I'm going to pull it out. If that equals my end genes, that's the end. Otherwise, I'm going to go over my current length and for all the possible chars. Uh, okay, let's see. Is this the reason? I'm just making sure is this able to add. Uh, Yep. And then that's it. Let's see. Okay, let's print this, I guess. Oh, so I'm taking it everything and then I'm not sure if this is how you do character dot to string. Let's add C. I think maybe that's the reason. I'm not sure. Okay, that's not the reason. So what's happening here? Let's print a new word. Is it even able to produce the right word? Okay, let's see the words that we are generating. A, C, G, T. Okay, the first word is changed. Okay, so it's able to generate the new word, so that's not the issue. Um, oh, I see. Because my bank set has not been populated. So I gotta populate my bank set for O string X in my bank set dot add X. Yeah, this makes sense. Let's see. Okay, so output is 2 right now. Oh, let's see why. So I start with steps of 1. I pull it out. If everything works fine, okay, so it has to start with 0. And then if I add, I do 1. And then, yeah, this makes sense. Okay, let's submit. Yeah, this works. Yeah, so the basic idea is similar to the word ladder. I didn't explain this much, but if you guys want to check that out, that's the video you guys should look up. And yeah, in terms of time and space complexity, yeah, this one is tough, which I don't know. So basically, it's like you go over, these are the number of nodes that you're going to go over, right? So each gene word is a word. So the graph would be O of n square, where n is the number of words in the bank. And then to generate each of these banks, it's going to be dot m, where m is basically the length of your word, so the length of your start gene. So that's your space and time complexity. Uh, but yeah, I mean, this is kind of tough, but yeah. All right. So that's it. Thank you.